Good day everyone. Today I will discuss to you the fuel cell and glucose sensor. But first, we proceed to the fuel cell. History of fuel cell. The first references to hydrogen fuel cells appeared in 1838 in a letter dated October 1838 but published in the December 1838 edition of the London and Edinburgh Philosophical Magazine and Journal of Science. Welsh physicist and barrister Sir William Grove wrote about the development of his first crude fuel cells. He used a combination of sheet iron, copper, and porcelain plates, and a solution of sulfate of copper and dilute acid. In a letter to the same publication written in December 1838 but published in June 1839, German physicist Christian Friedrich Schonbein discussed the first crude fuel cell that he had invented. His letter discussed current generated from hydrogen and oxygen dissolved in water. Grove later sketched his design in 1842 in the same journal. The fuel cell he made used similar materials to today's phosphoric acid fuel cell. In 1932, English engineer Francis Thomas Bacon successfully developed a 5 kilowatt stationary fuel cell. The alkaline fuel cell, or AFC, also known as the Bacon fuel cell after its inventor, is one of the most developed fuel cell technologies, which NASA has used since the mid-1960s. In 1955, W. Thomas Grove, a chemist working for the General Electric Company, further modified the original fuel cell design by using a sulfonated polystyrene ion exchange membrane as the electrolyte. How does fuel cells work? A fuel cell is a device that converts chemical potential energy stored in molecular bonds, into electrical energy. A proton exchange membrane cell uses hydrogen gas and oxygen gas as fuel. The products of the reaction in the cell are water, electricity, and heat. This is a big improvement over internal combustion engines, coal-burning power plants, and nuclear power plants, all of which produce harmful byproducts. Uh, I prepare to you a video on how does fuel cell works. So here's the video. Here's the fuel cell, and here's a lamp. As you can see in the video, we have two gas entry, and we have a anode, electrolyte, and cathode, and the exit where the water exit. First entry is hydrogen gas. The hydrogen gas enters to the anode side, and the oxygen gas enters to the cathode side. The hydrogen gas is traveling into the electrolyte going to the cathode side. So the hydrogen gas and the oxygen gas meet at the cathode side, and the electricity is produced. As you can see in the video, the water uh, generated is living at the water exit, and the heat is here. So that's 1 minute. Let's go back. Application of fuel cells. Stationary fuel cells are used for commercial, industrial, and residential primary and backup power generation. Fuel cells are very useful as power sources in remote locations such as spacecraft, remote weather stations, large parks, communication centers, rural locations including research stations, and in certain military applications. In short, fuel cell can generate a power. Second is fuel cell can be used as a battery. A fuel cell vehicle is a type of electric vehicle which uses a fuel cell instead of a battery or in combination with a battery or supercapacitor to power its onboard electric motor. Fuel cells in vehicles generate electricity to power the motor, generally using oxygen from the air and compressed hydrogen. Now, let's go to the glucose sensor. History of glucose sensor. In 1962, Clark and Ann Lyons from the Cincinnati Children's Hospital developed the first glucose enzyme electrode. This biosensor was based on a thin layer of glucose oxidase or GOX on an oxygen electrode. Thus, the readout was the amount of oxygen consumed by uh, glucose oxidase during the enzymatic reaction with the substrate glucose. This publication became one of the most often cited papers in life sciences. Due to this work, he is considered the father of biosensors, especially with respect to the glucose sensing for diabetes patients. Another early glucose meter was the Ames reflectance meter by Anton H. Clemens. It was used in American hospitals in the 1970s. A moving needle indicated the blood glucose after about a minute. Yeah, that's right. So, how does glucose sensor work? A glucose meter is a medical device for determining the approximate concentration of glucose in the blood. It can also be a strip of glucose paper dipped into a substance and measured to the glucose chart. It is a key element of home blood glucose monitoring or HBGM by people with diabetes mellitus or hypoglycemia. A small drop of blood obtained by pricking the skin with a lancet is placed on a disposable test strip that the meter reads and uses to calculate the blood glucose level. The meter then displays the level in units of milligram per liter or millimole per liter. Application of glucose sensor is it is used to measure the blood glucose concentration of a patient and are an important part of managing diabetes mellitus. And that's it. See you tomorrow.